So I have this vector. I don't know why it has the answer on it, but let's just pretend it doesn't. So I have this vector P1, P2, and notice it's not starting at the origin, but I want to make it start at the origin, so I say, okay, well, my new vector is equal to y2, the y2 minus y1, and x2 minus x1, so it's 4 minus 1, comma, 6 minus 2, right? So it would be 5, comma 4, just like it says. So 5, comma 4. That's my position vector. I take that vector and I move it down so that its initial point is on the at the origin. Does that make sense? Okay, good. All right. Okay, so we're going to start here. We have this vector. Let's see what I do here. Okay, I have a vector, v minus w. Well, there's my v and there's my w. But minus w, so I have, the w is going 2 in the x direction and 2 in the y direction. So I'm going to make it go 2 in the x direction, 2 in the y direction, in the opposite direction. That means this is minus w. Agreed? Okay, so now if I want to do A, I take that minus w vector and I attach it right here. There's minus w, and my answer to v minus w is from the initial side to the terminal side. This is v minus w. Okay? Does that make sense? Okay, good. If I want to do, let's just do C, because C has a lot going on. So I have 2v. 2v means right now my vector is 3 in the x direction and 2 in the y direction. So I have to make it longer by twice as long. So I'm going to make it 3 more and 2 more. So now my new v vector goes all the way to there, right? Yeah, Griffin, what's up? Yes, exactly. 6 in the x direction, 4 in the y direction. I double it, exactly. Then it says minus w. Everything's off scale. Here, let me just move it down here. So here, let's say we start here. There's my v. Okay, this is my 2v. Now my w has got to go in the opposite direction because it's minus w. So I'm not going to be able to do to scale. So let's say this is minus w. Again, I put it from the initial point to the terminal point. Okay? And then plus u, well, u is going straight up this way, right? So let's say that's u. Okay? Now my final answer would be, I start at the initial point and I go to the terminal point. So this is my vector 2v minus w plus u. Does that make sense? All right. Very good. No questions? Don't worry about the numbers because right now we're just doing it geometrically. Just like we did in Alex geometrically, we do it geometrically here. Okay? So I'm gonna take off all the stuff that I wrote over because it's all right here, and it's a better picture than I have. Sure. Okay. Let's put the. I was pretty close. I mean, it's hard to do without a. So let's begin. So we have. Hold on, let me get a color that writes on black. So we have 2v. Let's say if this is v, then 2v is twice as long, right? If w is going that direction, then minus w is going exactly in the opposite direction, right? So I'm going to attach that right here, and we'll call that minus w. All right? Let's see, make this a little longer. And then, let's move it up. And then I can say u, well, u starts here, and let's say this is u. Okay, so this is my initial point. This is my terminal point. And that when I add those vectors all together, this is the answer. The blue vector is the answer. The blue vector is 2v minus w plus u. Let me see if I have anything in Alex that has more than 2 vectors. I'm not really sure. No. They all have just 2 vectors, I think. Did that help, Damien? Okay, good. Any other questions? You know, I'll erase this again because the answers are all right here. I just wanted to show you how they get the answers. Okay. Okay, so now if we're given these vectors, now we're given actual values for vectors. I can geometrically, of course, I can graphically or geometrically find the answers, or I can also find them, of course, I'm sure you hope this would happen, well, of course it does, that I can find them algebraically. Because, remember, one of the rules says I can take minus 2 times the vector minus 3 minus 2, which distributes, so this becomes 6, 4. Okay? And so if you look at the first one, A here is minus 3 minus 2. If I multiply it by 2, I get minus 6 minus 4. But because I'm multiplying by negative, it goes in the exact opposite direction, just like we would expect. Okay? So I'm not going to do B because I think it's pretty simple. I'll just do C because just to show you that C, this is C, is just going to be minus 2u, which I already know is 6, 4, plus 1/2 v. Well, I just multiplied by 1/2, so it's 2, minus 3. And then I can just add them regularly, and I'll get 8, 1. And that's my final answer. So I think algebraically is pretty simple. right? There's nothing tricky about it. So any questions here? If you have a question, Griffin, just turn your mic on. Yes, I do. A lot. A lot. Vectors are really a chemistry, chemical engineer chemistry. Vectors are the way the atoms interact. I only know that because I had a graduate chemistry student in one of my classes once, so he told me all about it. It looked really interesting. Okay. I'm just trying to figure out how far I want to go. Just give me a second here, because I know that Damien had a question. It probably would help everybody. Let's see. I mean, I guess we could do this. This is really exactly the same as what we just did for polar. So we can find the position vector. We found out how to do that. We really just take the length of the y values, the length of the x values. And if we want to find the magnitude of the vector, remember, we're talking about vectors, and they're really just, if we know the vector, if I say this is 5, and I say this is 4, let me just make it something easier that we don't have to do a lot of arithmetic for. Like, let's make that 3, 4. Well, I know this vector, the length of this vector is 5, right? 3 squared plus 4 squared equals v squared. So the magnitude of vector v. And when I write it like that, it's called the magnitude, is equal to 5, right? And just like we did with polar, we have exactly the same thing for our reference angle. I can say the reference angle is equal to, or let me do it first straight out. I can say that the tangent of the reference angle is equal to the opposite over the adjacent, right? Y'all know that rule. So this would be 4 over 3. So I can say the reference angle is equal to the inverse tangent of 4 over 3, right? And exactly the same thing we did for polar happens here. Because the adjacent, we can say the cosine of theta sub r is equal to the adjacent over the hypotenuse. But they're using tangent, so let's do tangent. Sorry. Oh, no, I was doing a. Sorry. So I can say, let's pretend I didn't know it here. Let me take the x away. So I can say that A is equal to the magnitude of V, cosine of the reference angle. And the same thing for B, right? For the y value. Does this all make sense? Do you see how it's all related to exactly what we just did with polar, and it's exactly the same thing we do with all trigonometry? Is this all making sense? Is there any questions yet? All right. Yes. So let's say we have a vector in quadrant 2, and it has a magnitude of 15 and makes an angle of 20 degrees with the negative x-axis. So there's the picture. And we've graphed the vector. And it says find the horizontal and the vertical component. So we can say that we know that the horizontal, let's call this A, let's call this A, and we'll call this B, then A is equal to the magnitude of U times the cosine of theta, right? Good. Exactly. So here we would have A is equal, the magnitude of U is 15, cosine of 20 degrees. Anybody's got a calculator, I wouldn't mind if you did that for me. And B is equal to the magnitude of U sine theta. So this is equal to 15 sine 20 degrees. So cosine is let's just say 6.1 and negative 14.2. Oh, wait. 6.1 for cosine. I think you got that backwards, Luis, because the cosine should be longer. Cosine should be bigger than sine. Because it's only 20 degrees. Did you get it backwards? Okay, so if we look at this picture, we can see that the x value is bigger than the y value, right? So, can we try again? Do you need to do it? I guess I can do it. Alright, so my calculator. So I have 20 degrees cosine times 15 equals 14.1, and sine of 20 times 15 equals 5.13. Good. Now, that was just reference angles. So in that quadrant, the cosine is, oh, okay, no problem, no problem. So the cosine here is negative, and the sine is positive. And you could have used 160 instead of 20 if you wanted to. Okay? Does that make sense? Okay. As far as C goes, I'm not going to go over that right now because we're going to go over that a little bit later. So there's another way to write. I'll just say it real quickly. So for C, if you want, and this is what electrical engineers use more I's and J's for vectors. So we would write this as minus 14.1I, because I says that's the x value of the vector, plus 5.13j. That means that's the y value of the vector. Or I can write it like minus 14.1 comma 5.13. Okay, so there's both C's are correct. Actually, the graph here, yeah, these are equivalent. I's and J's are not like complex numbers. They're the x and y value of a vector. IJK is if there was a third dimension. But we're not doing three-dimensional vectors in this class. That's like Calc 3.